Okay, so today's lesson is on factoring expressions by the greatest common factor. So this is exactly the same as when we would simplify fractions by factoring out their greatest common factor. It's very similar to the factor tree we used to make, except for in this case, we now have variables and coefficients, not just the coefficients, not just the numbers. So my first step is going to be to label or circle each term in the expression. So what I'm going to do is put a circle around each term. I don't care about identifying whether they're like terms or not, because that's not the purpose of factoring out the greatest common factor. So once we've identified the terms, we've got our first term, our second term, and our third term. Then I'm going to factor these out just like I would do using a prime factorization tree. So first I'm going to factor out my first term. My first term is 12x cubed. So I know that 12, if I make my own mini factor tree, is going to be 2 times 2 times 3. And then I also have to take into consideration that I have x cubed, which is just x being multiplied by itself 3 times. So that's how I factor out that first term. I need to repeat this for my second term and my third term. So my second term, I'm doing the same thing. We know my second term is 30x squared. I have to think about what 30 is when it's factored out. I have 3 times 5 times 2. I just wrote here, here, and here instead of 2 times 3 times 5. Times x times x. And then last but not least, we are going to do the third term, which is 42x. So I know if I factor out 42, I can do 2 and 21. And then 3 and 7. So 42 is just 2 times 3 times 7, and then we just have 1x. So we have now written out the prime factorization of each term. That's here, here, and here. My next step is to determine the common factors of the terms, coefficients, and variables. Since I have 3 terms, I know that my common terms have to be common amongst all 3 terms. You can't just find the common factor on 2 of the terms because that's leaving out the third. We need stuff that's in common for all 3. So first what I'm going to do is I'm just going to start with this first term, and I'm going to see, okay, what does this one have in common with the others? So we've got a 2 here. Let's see if we have a 2 in the other ones. We've got a 2, a 2, and a 2. Perfect. So we know that there is at least 1, 2 in common with all 3 terms. Let's see if there's another 2. So this one has another 2. This one doesn't. So that one's not going to be a common term. There's a 3 here, a 3 here, and a 3 here. So we know that they all have a 3 in common as well. Now let's see how many variables they have in common. We have an x, an x, and an x. But even though these 2 have another x, the third one doesn't. So we're done. That's all of our common factors. So if I write out our common factors, it's going to be 2 times 3 times x, which ends up being 6x. So that is my greatest common factor of those three terms. What we are going to do with the next part is rewrite this expression so we're writing expressions for the remaining non-common factors. So what that means is if I am forgetting about the greatest common factor, so I'm just pretending those aren't there, what is left in this term? So I'm going to say, okay, in my first term, I have a 2, an x, and another x, which is just 2x squared. My second term, I have a 5 and an x. So that ends up just being 5 times x, which is just 5x. And then my third term is just the number 7. The way we are going to write our final answer is we're going to write the original polynomial as the product of the greatest common factor in the terms from the previous step. So what that means, we know that product is multiplication. So I am finding the product. So that's our 6x. And that's going to be multiplied by my terms from the previous step. So what I'm going to do is say this is 2x squared plus 5x plus 7. And that is my answer. Because what I have done is I have factored out a 6x from each term originally. So I'm going to box my answer so everyone knows that's my final answer. And I can even check my work. If I want to check my work, what I just need to do is the distributive property. Because if I do the distributive property, I should be able to go from this new expression back to the original. So I can write 6x, 2x squared plus 5x plus 7. And if I do the distributive property, I should be able to get my original expression. So 6x times 2x squared is 12x cubed. 6x times 5x is 30x squared. And 6x times 7 is 42x. And I can see that this is the same as my original problem. 12x cubed plus 30x squared plus 42x. That's what I have down here. 12x cubed plus 30x squared plus 42x. And that's it.